Hi, Dr. Revis here. In this video, I'll show you how to use the Spec 20 Spectrophotometer. The Spec 20 or Spectronic 20 is a single beam spectrophotometer operating in the 340 nanometer to 950 nanometer range with a spectral bandpath or intervals of 20 nanometers. It measures the transmittance and absorption of visible light through a solution as a calorimeter. The single band light source passes through the solution to measure the difference between the incoming and exiting light. And that is the definition of a single beam light source. It's one that passes through the sample to measure the light of incidence and the light being transmitted through the sample. These are the controls for the Spec 20. There's a sample holder, then the wavelength switch, which is a filter or slit that's adjusted depending on which wavelength you're operating in. When operating in a wavelength below 600 nanometers, the switch is shifted to the left. When operating above 600 or equal to 600 nanometers, the switch is shifted to the right. There's the on-off button, which is also the 0% T control knob. There is the 100% T, which controls the 100% T setting. There's the wavelength, and in front of the wavelength knob is a window that shows which wavelength the instrument is set at. And then there's an analog needle shown here. That needle reads transmittance or absorbance depending on whether you read the top for transmittance and the bottom for absorbance. The Spec 20 is an older instrument, however it is still a popular instrument in many general chemistry laboratories. There's also a Spec 20D that is a digital version of the Spec 20. It is otherwise identical in operation to the original Spec 20. In this presentation, we will show you how to use the original Spec 20. So here it is. Step 1, turn on the instrument using the 0% T knob. Step 2, turn the 100% T knob all the way counterclockwise. Step 3, select your wavelength for the experiment. Be sure to match the range of the wavelength based upon the wavelength switch, which is step 4. Slide the wavelength switch or the slit based on your lab experiment's wavelength. If the wavelength of your experiment is less than 600 nanometers, the switch will be shifted to the left. If the wavelength for your experiment is greater than or equal to 600 nanometers, then the slit will be set to the right. So these are your initial setup parameters. It's important to note, however, that step 1, 2, 3, and 4 can be carried out in a different order to achieve the setup. By the way, you'll know that the instrument is turned on if the red light is glowing. Next, calibration of the instrument. That involves step 5, 6, and 7. Step 5, turn the 0% T knob until the needle reads 0. Next, step 6, insert the blank cuvette sample into the sample holder. The blank sample is oftentimes water, deionized water, or a dilute solution of the sample you will be evaluating. Then, step 7. Turn the 100% knob until the needle reads 100. If you follow the first 4 steps, you will be turning the knob in a clockwise direction. That brings us to executing the experiment. Step 8, 9, and 10. Step 8, remove the blank and insert your sample. Step 9, read the absorbance on the bottom dial. Once you've recorded this data, repeat the experiment with a new sample at a new wavelength. And remember to check the wavelength switch. And note, however, that if you are carrying this experiment out at the same wavelength, as in charting several concentrations at the same wavelength, you can simply remove one sample, put in the other, make the read, put in your next sample, make the read, put in your next sample, and make the read, as long as they're being carried out at the same wavelength. It is not always required that you recalibrate with a blank. Oftentimes, at this point, once you've entered the experimental phase, you can simply continue to add sample after sample after sample, as long as you are carrying the experiment out at the same wavelength. So let's recap. There's the initial setup, which essentially allows you to get the instrument turned on. There's the calibration, which allows you to tune the instrument to the required parameters for the experiment. And then there's the experimental phase, where you execute the experiment. So there you have it, how to use the Spec 20.